Hello YouTube! In this video you're gonna see me making a part that I could probably have bought for $5, but I'm deciding to spend way too much time and effort to make my own. To understand the basic technical problem I'm facing here, for a renovation project of mine I need an adapter from 40mm clamp ring fitting, which is for underfloor heating, to a regular half-inch pipe threading for a thermostat. In this shot you see me disassembling the part. This is the 40mm clamp ring fitting, by the way. Taking out the compression rings and carefully removing the O-rings with a small needle in order to avoid damaging it. Keeping the O-rings intact is crucial here, otherwise I would end up with a fountain instead of an underfloor heating system. Part prepared, so I'm going ahead and chucking it in the lathe. I'm making sure not to squeeze too hard onto the part, since these adapters are quite delicate, and otherwise we would face the same problems as with the O-ring. Here you see me trimming off the axis with a hacksaw. To understand this shot, you need to know that this given part that I'm working with has two adapter pieces for underfloor heating pipe, and I'm only requiring one since the other side is going to be used for the half-inch adapter. Here you can see me start spinning up the lathe, making sure to go not too hard on those slats, otherwise I would risk jamming it and ruining the part. The machine you're seeing in the video is a 1928, approximately, Dolzer and Slotter from German production. The old lady may be a little bit slower than modern machines, but on the other hand I really enjoy its firmness. In this shot you see me using a carbide tipped cutter, which is not strictly necessary. High-speed steel would probably do just as fine, but the brass is really machining nicely, as you can see. Here I'm taking off the underside of the part. This would technically not be necessary, just for aesthetic purposes only, creating a nice and smooth surface so you can see the soldering properly. To understand the general background of this project, I've bought an old house in the beginning of this year, and I'm starting to replace some of the heating system with underfloor heating, but not all of it, by the way. In some rooms I'm keeping the old traditional radiators, and some other rooms, in this example a bathroom, is getting underfloor heating. So I'm not needing a complete regulation system for it, just a single room regulator is alright for me, and that's why I need this adapter. As mentioned earlier, I probably could have bought that part for cheap money, but this way it's way cooler and way more fun. You see me finishing the underside of the part and slowly starting to take it to final dimensions. The goal here is to get it at about 15mm in order to fit into a solder nipple that you're going to see later. But in this shot we are still quite far away from final dimensions. So you see me slowly removing the material. The brass indeed is machining nicely. Just to mention, by the way, per path I'm removing at about 0.2 to 0.3mm at a time. So as you can see I'm taking my time here. In this shot you can see me measuring the part for the first time. In the previous process it was quite obvious that we are still quite far away from the targeted 15mm. But here you can see we're getting quite close. 2 more passes and we should be done. Not overshooting the final dimension here is quite crucial, since we intend to machine in a shoulder, just a really small one, by probably 0.3, 0.4 millimeter, just to avoid the part from slipping too deep into the solder nipple, so we still have a chance to sneak that tin in there. See me measuring again, making sure we didn't overshoot already. Reducing the cut depth in order to cut that mentioned shoulder. In this shot you won't quite see it, but later on I'll show you a picture of it. Measuring that shoulder, making sure it's a tiny bit wider than 15 millimeter. Here I'm finishing the part with the hand file, just deburring her, so it'll slide nice and firmly into the solder nipple. In this shot you can see the mentioned shoulder. And here we're desoldering an old piece of pipe from a used solder nipple in order to reuse it. You see me using another fitting in order to hold it in the vise without damaging the threads. Just applying a little bit of flux to keep the tin less viscous and to make sure we get that pipe out nice and quickly. Here you can see me hitting the part with the torch, basically at full burst, to transfer the maximum possible heat into the part. If you watch closely, you see me being a little bit too impatient, trying to pull off the pipe without the tin already being fluid. There we go. The tin is starting to melt, and I should be able to pull it right away. And there you have it. In this shot you see me preparing the later solder connection, using a wire brush to clean the inside of the nipple. Really making sure to get every little bit of dirt, since this connection is going to be quite critical. We don't quite have the penetration we would actually need. We don't get the nipple far enough covered. So we have to make sure that the connection is good and that the solder flows everywhere and grabs to every surface it can. Here I'm using emery cloth to clean the machine part. Once again, making sure to get rid of all the grease and all the detergents we don't want in our solder connection. As you can see, I'm starting to tin the part. Once again, making sure to use plenty of it. Regularly I would use a little bit less, but in this case, rather a bit too much and some tin overflowing, instead of using a little bit too less and the connection not being solid enough. We're making sure to stipple it in every little corner of the part. And I'm even using it on the inside of the nipple, which I regularly wouldn't do, but in this case, as mentioned before, every help we can get. Cleaning off the excess flux. And pre-assembling the part. As you can see, it doesn't go in quite all the way, since there is some residual tin from the soldering we removed. And now I'm hitting it with the torch at a lower setting to really keep control and track of that heat and see where the tin goes. As we heat the part, the tin, the residual tin, should liquefy and it might slide right in. Here you can see it flush over. I'm starting to press it down into its final position. There you go. As you can see, it's not inside quite all the way. It's not touching the threadings, just to give me a chance of applying the tin properly. Once again, I'm preferring to use it rather a little bit too much instead of a little bit too little. And as you can tell, we're getting quite a solid connection here. Perfect, that should be airtight. Here you can see the final part, carefully inspecting the soldering. Looks good to me. And we can reassemble the part. Carefully sliding over the O-ring, making sure not to rip it. The compression ring. And there you have it. Finished. As you can see, it fits perfectly. So anyway, thank you for watching, like and subscribe, and see you next time.